A lot of people have the expectation that you could go out and buy any Alder Lake motherboard and pair it with any Alder Lake CPU. You might pick up the 12900K on sale and then want to pair it with a less expensive motherboard. This is a bad idea. I'm going to show you why. Alright, for our motherboard roundup, we've got MSI, ASRock, ASUS, and Gigabyte represented in our stack here. I accidentally messed some things up. We're going to do DDR5 boards separately. There is a DDR4 version of this board. We'll take a look at that. I reviewed the DDR5 version of this board separately, but we've got a slightly more expensive B660 motherboard, a less expensive B660 motherboard, depending on the day, and then an inexpensive B660 motherboard. Not all of these motherboards will handle CPUs the same way. It's a really sort of interesting situation. Intel historically has had PL1 and PL2. Those are, I mean, I'm oversimplifying here, but how much power the CPU is permitted to consume for whatever duration. In PL1, it'll use more power for a little while. It'll burst and try to deal with that workload, but not just power usage, but heat generation. And heat generation sort of becomes an issue. That 12900K, it can use 241 watts flat out sustained, and as long as you keep it cool, it will run. So you get a really interesting situation when you've got a 12900K or a 12700K or some other CPU, because if you can keep it cool and you can keep it fed with power, meaning that the motherboard can supply that power for a sustained period of time, it'll run with higher performance. Now, gaming is kind of a bursty workload. The game will be busy, the game will be less busy, the game will be more busy. If you have fewer cores, the cores stay busy longer, but in a nutshell, it's a bursty workload. Whereas like Cinebench is running flat out as fast as you can. And it's also a really weird situation because this is the i5, the i5 12600K. This is 10 cores. It's 6 Alder Lake P cores plus 4 efficiency cores, 10 cores total. It is a very weird situation we find ourselves in that 10 cores would be a thing that is an i5. Like, that's market competition doing that, right? I've also got the i3, which is 6 Alder Lake P cores. This is the i5 12400, which is 6 Alder Lake P cores. So 4 Alder Lake P cores, 6 Alder Lake P cores, 6 Alder Lake P cores, plus 4 efficiency cores. This is sort of the chain that we find ourselves going up in. There's also the 12700K. See, when I started doing this video, the 12700K was about $350, but you can pretty regularly find it, at least in the US, for around $300, and the 12400K you can pretty regularly find for around $150. Those are really good deals. The 12700K is interesting though, because it can consume up to 220, 230 watts. I mean, it's 12 cores. You've only lost 4 efficiency cores, and the 4 efficiency cores didn't use that much power in the first place. So with these motherboards, I'm going to start with the 12700K and see how these motherboards do in a sustained workload with the 12700K, and for gaming with the 12700K. That's 8 P cores and 4 efficiency cores. And then we can step down accordingly to see what CPU would actually work. Do we actually even have any overclocking headroom? Because this PL1, PL2 thing, not technically an overclock. That's just how much power the thing will use when it's running full time. If we have a little bit of headroom in any of these motherboards, we'll be able to overclock the 12700K just a little bit and have more overclocking headroom for the i5, the other i5, or the i3. It's a really interesting situation. For our test bench, we're going to be using the Sapphire Nitro Plus for cooling. This is a 360mm AIO. It's sort of new from Sapphire. It's their initial offering. I'm not going to go too hard on it. It is definitely an initial offering from Sapphire, but it's not too bad. But it's maximum overkill for this build. I mean, our 12400 has a 1000 watt power supply with a 6900 XT in it. That's overkill. But what we're testing here is the motherboard, so maybe it makes sense. Because I want you to be able to buy the 12400 with $100-ish motherboard, because that's a pretty good deal. First up, our Gigabyte board. At the time that I'm doing this video, this is around $140 US motherboard. That's dual PCI Express 4.0x4 M.2, 2.5 gig LAN. It has built-in Wi-Fi. Built-in Wi-Fi or not is going to make a bigger difference to price in this area than most things. The motherboard bundle is very basic. You basically get an I/O shield a movable Wi-Fi antenna. Take note here, other companies that include the really cheap antennas. Even on this inexpensive board, this is a good Wi-Fi antenna. A couple SATA cables, a couple M.2 screws. There's not even a manual, it's just an installation paper. If we take a closer look at our rear I.O., we've got two USB 2.0, a combination PS2 mouse. This is our Wi-Fi 6 interface here. Again, Wi-Fi makes a bigger difference for price in this area than one might think. We've got HDMI out, dual DisplayPort out. That's sort of a differentiator for this price class. Yeah, the USB interface is one USB 3.2 Gen 2 Type-C, and everything else is 3.2 Gen 1 plus 6 total USB 2.0. So everything is 5 gigabit except for this one Type-C, which is 10 gigabit, which is nice. You're not always guaranteed 10 gigabit at this price point. Of course, there's no Type-C front panel connector. You do have a single 30-pin connection for your front panel USB, as well as a couple of USB 2.0 headers here at the bottom. And standard front panel audio out, including SPDIF. Now take note of power delivery. We do have a heatsink on this side, but no heatsink along the top here. Ooh, it's going to be interesting when we get at our FLIR. Next up, the ASRock B660 Pro RS. Remember, this is our DDR4 motherboard from ASRock. It's got a similar configuration to many of the other boards, but not everything's the same. At the rear I.O., we have two USB 2.0 ports, a combo PS2 mouse and keyboard port, as we've seen on others. BIOS flashback, so that you can flash the BIOS after the fact. That's pretty handy. HDMI DisplayPort, USB 3.2 Gen 1, USB 3.2 Gen 1 under the gigabit LAN, so a total of 4 5 gigabit USB ports. And the LAN is just single gigabit. And then, of course, we've got our audio out. This motherboard is a full-size ATX motherboard. Sometimes you see cost-down motherboards come in micro ATX, but this is a full ATX. That does give us an extra X16 slot physical, which is X4 electrical through the chipset. That is PCI Express 4.0 by 4. It is also worth noting that the PCI Express by 1 slots are open-ended, which means that if you run this motherboard with like a PCI Express, by 2 capture card or something that uses 2 PCI Express lanes, it could still function in the PCI Express by 1 slot. The card will physically fit in there. It's just the extra bit of the card will stick out. So, interesting stuff. This motherboard does feature a total of 3 M.2, one at the top here, one here, one here. Well, technically 4 if you count the M.2 Wi-Fi, which is optional here. That is an E-key Wi-Fi interface. Another thing that I'm seeing that I like is big heat sinks on the VRM area for our RS Pro. Dual 30-pin connections plus USB Type-C. So this motherboard has a total of 7 4-pin fan headers, 2 at the top, 1 at the bottom front edge, 2 along the very bottom, and 1 at the midboard. This motherboard also has 4 RGB headers, 1 50/50 header at the bottom, and 3 digital headers, 1 at the bottom edge here, and 2 up top. We have 4 SATA connections, an RS-232 header, and a single USB 2.0 header for extra expansion. I feel like that we can't complain about USB on this motherboard because it's got so much USB connectivity for the front panel, USB-C and 4 USB 3.0. But you can use a breakout cable to go from one of these back to the back panel, so you get even more rear USB I/O. On to the next board, the ASRock B660M Steel Legend. Now this one is a micro ATX motherboard, but it costs about $10 more than the RS660. But it's got a 2.5 gig LAN and some other features we'll take a look at. So in the box you get a Steel Legend keycap, some M.2 hardware, rear I/O shield. Also we got our dual SATA 6 gigabit per second cables. So for the Steel Legend, what do you get for the extra $10? Well, notice we've got 2 heat sinks above and below. It's a 9-phase VRM, they say on the box. We'll test that. You got your M.2 here, M.2 for Wi-Fi, as well as an M.2 down here. It's really 2 usable M.2 plus an M.2 E-key for Wi-Fi. Then we've got our DDR4 DIMM slots, USB-C front panel, and a 30-pin front panel. 4 plus 2 SATA connections, dual front panel 2.0, USB 2.0. We got a total of 5 4-pin fan headers. We've got our PCI Express 5.0 by 16 expansion slot, and then 2 PCI Express by 1. The ends of the slot are open, so you could use a slot with more lanes. Just know that it's going to run at fewer lanes, so the card may not function correctly depending on exactly what it is. For the rear I/O, we've got a combo PS2 mouse and keyboard, 2 USB 2.0 ports, 4 5 gigabit USB ports, a Dragon LAN 2.5 gig, that's based on the Realtek NIC. We've got a 7.1 audio solution based on the Realtek ALC897. We've got DisplayPort out and HDMI out for your iGPU, and a BIOS flashback button. We have 3 digital RGB headers, 2 at the top here, 1 at the bottom edge, and a 50/50 analog RGB header. Next up in our test is the ASUS PRIME B660M-A D4. Why do they come up with these names? This motherboard is interesting for two reasons. One, the first one that I got was DOA. Can't hold that against ASUS. Sometimes weird things happen. Don't know. This is the replacement. It works fine. This motherboard also is really weird in another respect. It has had pretty severe price fluctuation. At the time that I'm shooting this video, it is $130. I actually paid $140 for this one, so it's already gone down $10 in price. I've seen it as much as $160. This motherboard does not include Wi-Fi, so a little bit of volatility in pricing. Not the most expensive board, but also definitely not the least expensive. This motherboard does have two USB 10 gigabit ports at the rear I/O, 4 USB 2.0 ports, one DisplayPort, 2 HDMI, one Intel gigabit, single gigabit Ethernet, 3 audio jacks, and a PS2 combo mouse and keyboard jack. It has 2 M.2 slots, 4 SATA connections, 4 5 gigabit front panel USB connections, and 1 Type-C front panel USB connection. So ASUS has got the USB ports. I've prepped their board for installation. A couple things I noticed right away. There's no heatsink at all for either M.2. I mean, that's a cost down board. Heatsink yes, heatsink no at the top. This does not bode well. We have otherwise a pretty intelligent layout. This X16 slot's actually only X1 electrical. This one is X4. Not a terrible layout. And this PCIe slot is limited to PCI Express 4.0, not 5. For the rear I/O, I think I would have much rather had 4 5 gigabit ports than 2 10 gigabit ports, but maybe that's just me. Okay. Let's break our results down. The first question was, can we buy a B660 motherboard and run a higher end Intel Alder Lake family CPU in it? Because, things looks like too much has been cut. The answer from initial testing is it depends. A 12900K and a KS is simply too much for these boards. I mean, it might work, but you're going to leave some performance on the table with that CPU. And what kind of performance are you going to leave on the table? Well, it's not gaming performance. I mean, the gaming performance of the 12700K and the 12900K is basically identical. It's the productivity multi-core in the 12900K that is really the difference. And it also needs more wattage, which is really the differentiating factor on these lower cost motherboards. How much power can you deliver to the CPU? I mean, the 12700K really is essentially the same as the 12900K. I mean, okay, the 12900K, the clocks are just a little bit higher, and the KS is a little bit higher than that. But they're not good deals for gaming. If you're building a gaming computer, they're the highest end thing. The 12700K is probably the best bang for the buck at around $300 to $350 at the time that I'm making this video. You can get the 12400, which I also think is great, and the 12600K, and get 6 Alder Lake, the P cores. But motherboards when the 12700K launched was over $200, more like $300. Can you get a reasonable motherboard for $150 to power that 12700K and on down? That's what I set out to answer. Now our test setup and everything else is pretty simple. We've got a Radeon RX 6800 XT. This is the highest end GPU that I think you'll probably test on this system. We want to know if any of these boards lower overall game performance because the CPU is bottlenecking or something about the motherboard is throttling or something is slower than it should be. So if the game performance is not worse with this GPU as we switch out motherboards, then it's not going to be worse with any lower tier GPU as well. I also tested with DDR4 3600 with a command rate of 1. This is pretty fast memory for DDR4, and it will be a challenge to less expensive motherboards. You need more ground planes, you need better routing. Now, it's probably also true that if you're building a budget build or building a lower cost build, you're not super concerned with memory speed, but in case you are, we tested. Our SSD was a Sabrent PCIe 4 terabyte SSD, plenty of room for everything. Again, maximum overkill. And our 360mm Sapphire AIO, also overkill for this build, but done to make sure that the main variables are related to the motherboard and not really any of the other components. That doesn't suggest that you need to go this overboard when you're doing your build. That will let us test the CPU to see if the CPU works as good as it possibly can, because if the same CPU is faster in one board than another and it's not down to an out-of-the-box overclock, then that's something we need to talk about. That's maybe a problem. But also, do we have a little bit more overclocking headroom. Maybe there's another trade-off for other features. Until the CPU itself is properly supported, we can't really talk about the other features. And we also can't really talk about the cost trade-off unless the motherboards properly support the highest end CPU that you want to run. So at the bottom of our results stack is the Gigabyte B660M DS3H. I really, really think they made a big mistake not having a heatsink on the topmost VRM. But also, at the same time, it was a little impressive that it worked as well as it did without a heatsink. In our thermal testing and our FLIR thermal imaging, they do overheat, and they will cause our 12700K to throttle down when it's allowed to turbo all the time, for basically PL2 all the time. And that was a little bit of a rug pull on Intel's part. Right before the Alder Lake CPUs were launching, they said, hey, we'll just let CPUs turbo all the time. We paid $140 for the board, but without Wi-Fi, it's also around $120, making it the cheapest motherboard in the Roundup stack. And I will concede that for gaming, it is serviceable, but for Cinebench, it's going to be throttle city after about 30 minutes to an hour. With good airflow on our test bench, the VRM components, they are rated for 115C, and Hardware Info 64 only reported 100C, but we were seeing well over 100C on our thermal imaging. To say nothing of the actual hot spots. Gaming performance is not going to be hitting the board as hard as Cinebench, so gaming performance was basically okay. It was also a little bit weird that out of the box, Gigabyte seemed to be configured to allow the 12700K to turbo all the time. Now that is something that Intel actually supports, and technically this generation is not really considered an overclock, whereas in the past, multi-core enhancement was kind of considered that. It's not exactly the same thing, I'm glossing over some details here, but basically, Alder Lake is permitted to use a lot more power, and that's on by default, when I think on this board it probably should be off by default. Next on our lineup was the ASRock B660 Pro RS. This is also around $140, but it has no onboard Wi-Fi. And out of the box, it has the more conservative CPU settings. ASRock calls it dual tau boost. So initially, the performance was a little bit lower than the other boards that we tested. However, enabling this, and only this, allowed the CPU to consume 190 watts, which is kind of what I expected and what the other boards were basically doing out of the box. Our VRMs would heat to around 90 degrees C, but with reasonable airflow, this isn't a problem because they have a heatsink on both sets of VRMs and everything there. Game performance was unaffected, and initially the 3600 memory trained at a command rate of 2T, whereas on other boards, this same memory trained at a command rate of 1T. However, I was able to manually select 1T training, and that was stable throughout testing, including both warm and cold boots. So the 12700K is the absolute maximum limit for this board, and that is, it's my opinion that this is sort of the minimum board that you want to go with if you're going to get a 12700K and your CPU is going to use about 200 watts. If you're going to use less of a CPU, then you're not going to have a problem, but also this board lacks 10 gigabit USB, and you're probably going to want to look at some of the other feature details of this motherboard before you make a final decision. The ASUS board is really interesting when it comes to thermals. Letting it run for a long time is a little less interesting, but let me show you what I mean. It telegraphs what its problem is going to be. Let's see if you can hear. So I'm just running Cinebench from being cool. And it's not really that the CPU is struggling. Out of the box, this motherboard will run that i7 at 210 watts, and it configures PL2 for 241 watts, at least according to Hardware Info 64. The problem is that after a while, it'll throttle down. You can see that in the CPU temperature. Initially, the CPU temperature is like 80, 88 degrees, or 360 is keeping up with it. It is a little bit, it's not an overclock, it's that CPU thing I was telling you about before. The CPU's running within spec, but at 210 watts. But eventually the VRM on the motherboard can't keep up. The CPU temperature falls off to 60-ish degrees C. Clocks fall off. And you can hear the CPU fans working not quite as hard. Notice that even though Cinebench is still running, their fans have backed off. It restarted, you can hear that in the fans. And now they've backed off again, even though Cinebench is still running. What's going on? The VRMs. The VRMs are burn your finger off hot. Even with their single rear exhaust fan, which is responsible for a decent amount of airflow over the board, it just isn't enough to remove heat from a sustained workload like this. It's definitely on the struggle bus. After about an hour of running Cinebench, it's difficult for it to make it through TimeSpy without crashing. The reported temperature in Hardware Info 64 was only about 93 degrees C, but the FLIR, especially on the one set of VRMs, was quite a bit warmer than 93 degrees C. Is that related? I don't know, but it's concerning you can't make it through 3D Mark TimeSpy. Overall, for gaming and other benchmarks with this motherboard, it's a little bit of a mixed bag. If you run Far Cry 6 for an extended period of time, eventually it will start to thermal throttle at the default settings for the 12700K. You can get a good 12700K experience on this motherboard, but it's necessary to dial the settings down a little bit. The out-of-box defaults push that i7 12700K just a little bit too much. In our full lineup of other motherboards, the PL1 value, the wattage value, basically like how much is this using when you're running Cinebench, I mean, I'm oversimplifying a little bit, is reported to be between 190 and 220 watts with our i7. And of course, the more power the CPU uses, the better it's going to do in benchmarks and everything else. Mostly artificial benchmarks. It doesn't make much of a difference in gaming. But there's something weird going on with this ASUS motherboard and the defaults because it's using just a little bit too much power. And because it's using a little bit too much power, it eventually will throttle, even in my relatively open-air test bench system. That affects the benchmarks. If the system is cool, then the quick benchmarks like the Babco Sysmark and everything else look good. But when it's been on for a while and it's been heating up and it's been running Far Cry or Cinebench or whatever in the background, then the performance is not as good. Our overall score from Babco Sysmark is 2118, which isn't the best score of the bunch, even though the CPU, the power that the CPU is allowed to use on this board is a little higher than average compared with our other boards. In the end, attaining system stability by dialing things down from the defaults just a little bit in the ASUS BIOS made a pretty stable system, but I don't think you should have to do that, and necessarily you're going to have the skills to do that out of the box. It was very surprising, this result. So I don't recommend this ASUS motherboard for the 12700K. Should be fine for the i5 12600K and below, but yeah, wow, surprising. Very surprising. And then there's our ASRock Steel Legend B660. This board cost more, but it's definitely a spend more, get more kind of a situation. I couldn't find it without Wi-Fi, but with Wi-Fi, it was around $150. So that's only about $10 more than the, non-Wi-Fi version theoretically would be. But the $10 buys a lot. Better VRMs, and the Steel Legend had no problems in games or synthetic workloads. In fact, I even pushed a 5 gigahertz overclock, pushing it beyond 200 watts, and that Steel Legend handled that like a champ. With this board, I did need to tweak a few things in BIOS, but my 3600 memory worked perfectly right out of the box. In Babco Crossmark, it scored exactly where I'd expect a non-throttling, completely unleashed 12700K to score. I think the Steel Legend would probably be my overall recommendation if you're on a budget and if you're buying a 12700K or less Alder Lake family Intel CPU and you're planning to, juice it a little bit. In fact, the Steel Legend's probably overkill if you're going to get one of the i5s or even an i3. I mean, to be sure, if you buy a Z690 board, you will be getting more features and better stuff. And if you buy a higher-end B660, you're going to get more features and better stuff. But you can have the absolute best gaming performance that you can get on the Intel platform without buying the 12900K or the KS, and even without buying a $300 motherboard. This is it. Even with the worst motherboard here, a gaming type workload with the i7 was not really a failure per se. Just wouldn't be my recommendation because of the aforementioned flaws. Now for the DDR5 boards that I mentioned before, I've got a separate review of the MSI Mortar B660, but I've decided to break the DDR5 boards out into a separate roundup. This video is already getting kind of long, and I think it's a given that the DDR5 boards are going to cost a little bit more because DDR5. So we'll do a roundup of DDR5 motherboards next. So if that's something you'd like to see, or you've been considering a board, or lamenting over a board, or obsessing over a board, let me know in the comments below what DDR5 B660 boards you've been considering, and I will probably pick it up from Newegg or Micro Center or somewhere and do a roundup like this with B660 to see how it goes. Now, to be sure, I think the 12400 and the 12600K, those are also really good value CPUs. Both of those, you get 6 Alder Lake P cores, the big cores. It's just a question of whether you want any E cores or not. I mean, an i5 that is 6 P cores plus a bunch of E cores, that's a lot of cores in an i5. That's kind of bananas. That's going to work fine in any of these boards. And the i5 12400 and the i3 that I was showing before, all of those will work fine in these boards for even extended workloads. So we may actually be able to look at some of the even more low end, like maybe the 610s. I don't know. I'm Wendell, this is Level 1. This has been a quick roundup of B660 motherboards that are about $150. I was kind of surprised that they generally worked as well as they did for rendering non-Cinebench type workloads. But the feature differences in terms of what you get on the board, the NIC, the audio, the M.2 interfaces, whether or not you get Wi-Fi, that does make a big difference in price as well. So if you have any questions or thoughts or anything you'd like to share, join us in the forums at Level 1 Techs. I'm Wendell, I'm signing out, and I'll see you there.